Good morning to all. Am I audible?
Yes, sir. Good morning, sir.
Good morning. Yeah. So let's start lecture 4 without any delay. I will have a bit of a revision from the previous ones. Then we will start off. Just a second. Yeah. So let us see all the types of converters that are available for making our electric drives. Okay. So just a second. Where is it? Okay. Okay. So for the AC to DC converters, as we all know, it's called a rectifier, right? And to control the amount of voltage, we need to have control rectifiers. So in the earlier ages where power electronics was not there, the fixed voltage AC was given to an AC motor, whereby it was coupled to a DC generator, and the variable voltage was obtained by changing the excitation field. Sorry, just a second. Okay, so then okay, some window is coming. Just give me a few seconds. Just got- I need to get this window out. Okay. Okay. Got it. Okay. So then another technique was that the fixed voltage AC was given to an induction motor, whereby uh, yes, so whereby it was coupled to an alternator, and this alternator, when it rotated, produced a three-phase AC voltage. Now this three-phase AC voltage was given to a diode rectifier, which gave a DC voltage, and the variation in the DC voltage was obtained by changing the excitation field, right? Then came the era of power electronics. Not so much, but the diode rectifiers were present of higher amperes, higher capacity. So the fixed voltage single phase or three phase was given, after which an uncontrolled rectification was carried out, as you all know all the circuits there. Then the diode rectifier gave a fixed DC voltage. What is the example of this? It will be a straightforward single phase uncontrolled rectifier, right? Yeah, please give me a reply. I have to be confirmed that you were there. Yeah, am I audible? Deep, am I audible? Puran, Akash?
Yes, sir, audible.
Yeah. So sometimes keep on asking me questions, because it becomes very hard to detect whether it is online or not. Right. And then this is for single phase. If you go for three phase, you need to attach one more leg to the thing. So it becomes three phase. Yeah, then it becomes three phase. So it was all uncontrolled rectification, right? Uncontrolled means there is no control over the output voltage, right? So then what to do? You need to control the voltages, right? So then came the half control thyristor rectifier. Here one more thing was actually practiced. It was usually given through a variable. So what is this? This is an auto transformer, right? This is a symbol of an auto transformer. I should go to a new page. Okay. So if I wanted to have a variable output, what I want to have, I will give a AC voltage to a auto transformer, and will take out the output, give it to a uncontrolled rectifier. Have you seen auto transformers in the lab? Variac.
Yes, sir.
So by doing this, so by changing the tapping here is the tapping, right? If you put it downwards or upwards, then what will happen means if you rotate this tapping right side or left side, means anti-clockwise or clockwise, then it will give a variable voltage. It will give a variable voltage, right? So it is now okay. So this can be either 3-phase or single phase. If it is in 3-phase, then you have to have a 3-phase variac. This is a variac, which will give a variable AC voltage. AC voltage is variable, and it will give a variable DC voltage. Okay, so this is still in practice in some labs, including our labs also, where the variable DC voltage is obtained by changing the variac. But this is not in the application world. It is just for the prototyping world. And then comes the world of thyristors, whereby the thyristor came into operation. With the availability of thyristors at low costs, what happened? They used half-controlled thyristor rectifier. So what is that? Semi-controlled thyristor rectifiers. Then it became a variable DC voltage. I hope I did not need show you the half-controlled rectifiers. What is that? Semi-controlled. So two of them will be thyristors and the other two will be diodes. So by using that, you can either go for symmetrical angle or asymmetrical angle, right? Please ask me questions if you have any problem, and don't just sit there quietly. So AC to DC converters, so fixed voltage, single phase or 3-phase, now can be given to a fully controlled thyristor rectifier, which will give you a, so the circuit diagram is given here in the here. So you see AC voltage is being given to a fully controlled thyristor. What is the formula of this? VDC equal to? Yeah, can anyone tell me?
2 VM pi.
Huh?
2 VM, 2 VM, 2 VM upon pi.
2 Vm by pi, but where is the control parameter? How will you control the DC voltage?
Cos alpha.
Yes.
Cos alpha.
Cos alpha, right? So this is the thing. So by changing the alpha, you can change the DC voltage, right? And then fixed voltage or single phase or 3-phase AC, you give it to a transformer. That is a transformer with taps, auto transformer, which I told just some time ago. Auto transformer. And then you get a variable voltage AC, which you give to a diode rectifier and get a variable voltage DC. As simple as that. And then let me clear out. Yeah. So now you have fixed voltage, a single phase or 3-phase going into a diode rectifier, which will give you fixed voltage DC. And then you can employ a chopper. Chopper, I hope you know. What is that chopper? Here you can have a buck converter.
Boost converter.
Yeah, you can have here a buck converter, right?
Yes.
You can have here a buck converter. If you want to decrease the voltage, say it is 230 volt AC. Say it is 230 volt AC. So let me show you the entire diagram. Just a second. Yeah. So what you can have is you can have this AC going into a rectifier, uncontrolled rectifier. No issue with that. And this uncontrolled rectifier, it will give here a fixed amount of DC, right? This can be now, this is an input capacitor for the chopper. This can be now given to a what? This is a buck converter. Hopefully you remember.
Yes.
Yeah. So we have done a numerical on this also, right? So here you see this side is a, what is this? This side is a uncontrolled rectifier. And this side is a
Chopper.
chopper. So which one is easy to construct? Is it easy to construct a fully controlled rectifier or this configuration?
I think
Which is
this
more
configuration.
expensive? Yeah, this configuration is very cheap to manufacture, right? You don't have to have 4 thyristors. You have to have only 4 cheap diodes. These diodes must be costing around 10 to 12 rupees, right? So you get 4 diodes and you get a switch. This switch will cost you around 100 rupees, and then you have the LNC components done. So this will be a just cheaper version to get a. This will be cheaper version to get a controlled DC. Control DC. So in case this is a 230 volt AC, then what you will get is around 325 volt DC here, right? And if you want to decrease it, say you want to go for 0 to 50 volt DC, then you can obviously have this here. The load can be a motor itself, and by changing the duty cycle of this switch, that is, you can change the pulse width of this switch. The output will be D into V in. I hope you remember. After giving the semester, I think you have not forgotten it.
Yes.
So what will be the output? D into V in.
Into V in.
So it is a completely linear thing. See, it's completely linear. If you change the D, the output will change and the speed will obviously change linearly for a DC motor. So things are linear. So it is very, very important for control. If things are non-linear, then it is very difficult. And if you want to have a 4-quadrant chopper, then also you can add this circuit to this chopper, and then you can have a complete control, 4-quadrant control of the DC motor. Is it not so? This is the circuit which I actually developed. While I think you have remembered that I developed a prototype of a 4-quadrant chopper, and I showed it in the lab, in the online lab. So that circuit was based on this.
Yes, sir.
So I converted the 3-phase into DC by using 6 diodes, 6 pulse rectifier, and then use this 4-quadrant chopper to control that 1 HP machine, right? So it was working perfectly. Yes.
Can you explain that circuit again, sir?
Yeah, sure. Yeah. See, first of all, in order to have 4-quadrant chopper, what is the circuit?
Yes, sir. This again one more.
Yes, and with each you have a bypass.
Thyristor.
No, this is not a thyristor. This is a bypass. This is an inbuilt body diode.
Diode.
Right, inbuilt body diode. Actually, this switch is actually
MOSFET.
IGBT or a MOSFET. Right. This is actually IGBT or a MOSFET.
MOSFET.
This switch. MOSFET is where the power rating is a bit low and the frequency is a bit high. I personally used IGBT because it was giving me more power at lower frequency and the cost was half the cost of a MOSFET. My IGBT was H20R1203. H20R1203, it is used in induction cooktops and its cost was around 55 rupees. Right, and I had an option of a MOSFET which costed me 110 rupees. So I'll definitely go for the IGBT. Na?
Yes, sir.
Now, where is the machine located? The machine is located here, right? This is the DC motor. This will be inside actually. This is the DC motor, right? Now tell me, where will you get the DC supply? You have what? AC supply, na? Either you have 2-phase or a single phase. In the lab, I got the 3-phase, luckily. So in case you have a single phase, 230 volt AC, tell me how will you give the DC supply? Yeah, just give me a thing now. What has to this 4-quadrant chopper? You know what will happen?
It might burst. It might get burst.
Now, why will it? will it burst? Tell me first of all. Say if you attach a AC supply here, right? You want to
Yes,
do
sir.
this. So in the
Yes, sir.
positive half, what will happen? See, something or the other will happen in the positive half, right? But what will
Okay, sir.
happen in the negative half? Just see it. 230 volts AC, two diodes are in complete short circuit. Did you see it?
Yes, sir. Yes, sir.
This, and similarly this and this. So 4 diodes are in complete short circuit. The entire thing will blow up,
Yes, sir.
right? So
Yes,
you
sir.
cannot go for this. So what do you
AC
need?
supply.
What do you
DC.
need? You
DC
need
supply.
to convert it into what?
DC. And
DC.
then
So you add 4 rectifiers if it is single phase. In case it is 3 phase, go for 6, and then you attach it here. Got it?
yes, sir.
So this is not possible. This is possible. So what will it be? 325 volt DC approx. If this is 230 volt AC, is 50 hertz. Now this circuit will have 325 volt DC, and then by changing the duty cycle and all the 4 quadrant operations, how it happens. In case you have forgotten, just go back and just study it out. So then you can carry out the operations. Now is it okay?
Yes, sir.
Yeah.
Sir, but why are we doing this? I mean,
Huh?
converting it into DC and applying it to 4 quadrant chopper. What is the necessity?
Necessity is the application. In any application, say you want to have a electric car, sorry, not an electric car, say you want to have a control application, right? So see, necessity will depend upon the application, right? We are here to design any universal type of design which will give you the any desired result,
Yes, sir.
right? So you might have a control application which needs the 4 quadrant operation of the system, of the motor, right? Say for example a lift always needs a 4 quadrant operation, right?
Yes, sir.
There will be other applications also which we are not aware of right now, but
Yes,
the
sir.
situation can come just like my thing. I needed to give you a demonstration of a 4 quadrant chopper, right?
Yes,
So
sir.
where will I get 325 volt DC in the college? Is there such a large battery? Even
No.
if a battery was there, it would have 12 volts. And if I wanted to get 300 volts out of it to 12 volt, how many batteries would I need in series? Just think about it.
Around 20.
30, around 30 approx, 20 to 30 batteries,
Yes, sir. 20 to 30
right?
batteries.
So will the college give me so many batteries just to make a demonstration?
No, sir.
Think about the cost. So what I needed, a cheap solution, right?
Yes,
so that
sir.
I can show you people that the demonstration. So this was my application, right? Your application might differ from time and place, right? So I made a diode rectifier and I attached a chopper to it, and
Yes,
then
sir.
you already have seen it. It's in my YouTube channel also. You can just go and recheck it. And then I
Okay.
made this 1 HP machine which was there in the college, and then it happened automatically, and I controlled it using my smartphone. So that was the experiment, right? So any more question on that?
No.
Yeah. Okay. Okay. So now an AC to AC voltage controller is in the slide. So just tell me an example. The most
Inverter.
famous example.
Acha. AC to AC converter.
AC to AC. Inverter is DC to AC.
Hmm.
So AC to AC, say 230 volt AC.
Buck boost.
No.
No.
AC to say 10 volt to 230 volt AC, it will provide. You have to have an AC to AC voltage controller which will give you a range of 10 to 230 volt AC. Any other one wanting to answer may answer in the chat box.
The transformer.
See, that's the most popular example of an AC to AC voltage controller. What is it? AC to
Sir,
AC
triac
voltage.
or fan regulator or triac,
Yes, fan track. It's not a triac.
track.
It's a triac based, right? It's a triac based. Right. So what would be the circuit? So earlier ones. So going to the earlier versions, not the recent one. An AC to AC voltage controller, when triac was not present, what was present? This huge auto transformer. I hope everyone has seen it. Has everyone seen this in the college? This needs to be rotated either clockwise or anti-clockwise. Yeah, any doubt on that? Please
No,
give
sir,
me
I
your
haven't seen.
responses.
I
Ah,
haven't
you
seen.
haven't seen it? Okay, you will see it. This is a simple and auto transformer, right? If you have not studied auto transformer, please study in the electrical machines section. After transformer, you will have auto transformer, right? So in auto transformer, what you give a 230 volt AC, and you can get a range in between 0 to say 0 to 230 volt also, or more than that also, depending upon the turns ratio, right? So you will have, if you just turn this thing, then what will happen? You will get a variable voltage. You will get a variable voltage on the output. So output will be obtained from here. So this is the output, right? So if you turn it right and left, you will get an output varying with the tappings. But it becomes very bulky. It would be in the its size would be uh, approximately the size of a 5-liter pressure cooker, right? I hope everyone has seen that 5-liter pressure cooker in your homes. Yeah, anyone not seeing it? So its size will be much more than that pressure cooker. So it is very bulky. And do you want to control your fan using this thing? Do you want to attach this whole AC controller in the wall? It's not
No,
possible,
sir.
right? It's not possible. So this option is not valid for applications. It is good enough for the labs. So what do you have? You have a track, right? So earlier when track was not there, the fixed voltage AC or AC voltage was given to auto transformer, and then it was lowered. Now auto transformer came with taps, so you would have got variable voltage. Nowadays this is used. However, it will deform the waveform, obviously. So what is the circuit for this? What is the circuit? Basic power circuit. I hope everyone knows this.
Yes, sir.
Everyone has this in your homes. So what is the power? What is the circuit? The circuit would be, so this is something which you did in the lab. 2 thyristors connected in anti-parallel, and you have the load, right? For a thyristor, the circuit would be this. Sorry for the diagram. So this is a track, right? And this is a combination of 2 SCRs, right? This would be the load. In your case, it would be simply a fan. This will be RLE load also. So this is the example of AC to AC voltage controller. Any doubts on that? Yeah. However, there is a no change in frequency is there. So what is the difference between using a auto transformer and this small fan regulator? What would be the difference in the output? Why in the labs we don't use this for our experiments? You know the reason? See, an auto transformer is a way, it is much more costlier than a 30-40 rupees fan regulator, right? But yet we do not use that thing in the lab. Why? Any idea? You can write in the chat box. Someone not wanting
So
to
can you
speak out
repeat your
can write.
question?
Say an auto transformer which you saw, it's so heavy, it would have costed 2 to 5,000 rupees, right? Depending
Yes, sir.
upon the capacity. But a small fan regulator would cost you.
Sir, I can't hear you, sir. Sir, are you there?
Yeah, am I audible? Hello? Hello?
Yes, sir. Yes, sir.
Yeah,
You're audible.
the power went out in the college. So there was a sudden blackout. Anyways, let's continue with my mobile internet. So I'll be switching off my video because it will consume my bandwidth and things will go slower. Okay. So is my voice coming properly?
Yes,
Yes, sir.
sir.
Yeah. Please keep on pinging, right?
Okay, sir.
So, okay. The question was that why we don't use this auto transformer in our okay, so the question was that why we don't use this small fan regulator instead of the auto transformer. It costs hardly rupees 90, and that auto transformer would cost you around 2 to 5,000 rupees, right? But in the lab, why we don't use that? Any idea? Thing is that an auto transformer will, it is just like this, and it will not distort the waveform. Means input is sinusoidal, output will also be sinusoidal, right? The magnitude will vary, but the frequency and the type of waveform will be the same. But in case if it is thyristor based, sorry, triac based, then the problem comes out that if the input is sinusoidal, the output will be a non-sinusoidal. I hope you know about this.
Yes, sir.
Okay, so it will be deformed. So the
But sir, that
apparatus,
would be a, I mean, cut off part, na? It
yeah,
will be a.
cut off part, but that is the problem, na? The more I turn the alpha, if alpha is more,
Hmm.
the waveform goes out of shape, right?
Yes, sir.
If alpha is more. So what am I getting? I am getting a reduced AC voltage, but the thing is that I am going out of the waveform. So my device, my testing things might need a complete sinusoidal wave of a lower magnitude or a higher magnitude, but I cannot compromise with the waveform, right? So that's why these small AC voltage controllers are not used in labs, right? And because of the bulkiness of this auto transformer, it is not used in all the buildings and all. You will never find an auto transformer fixed onto the wall just to control a fan. You know that in that way you would incur more cost than the fan itself. I hope you understood it. Okay, so now era of DC-DC converters, choppers. So what we have a fixed DC voltage and we need to have a variable DC voltage. Now don't ask me why. You tell me why we need this thing.
Why variable, sir? It can be like 12 to 6 or 48 to 12.
Why variable? You know why variable? Because we are dealing with drives, right? If you are
Yes,
dealing
sir.
with drives, then we are dealing with motion.
Yes,
And
sir.
if we are trying to move, then we need to control the speed also.
Yes, sir.
You cannot drive a vehicle at constant speed.
Hmm.
Say if you want to start, that means you are accelerating. If you want to go at a fixed speed, then then it's okay. Then you want to stop, then you are deaccelerating also, right? But if your motor is getting a fixed voltage, say 12-volt voltage, will you able to stop? No,
Yes, sir.
right? Yes, you can be able to stop if you brake severely, but that would mean that you are harming the motor itself. So you need a variable voltage DC. You got the point. You want to have a variable speed, because we are
Yes, sir.
concerned with electric drives, not with LED lights that needs a fixed voltage, right? So that's the
Hmm.
thing. Now, how many choppers are there? Say class A chopper. That is a buck converter which will provide you power flow from the source to the load, right? And then you have class B choppers which will provide the power source from the load to the source. Then you have class C chopper which will provide you both direction power flow. Is it not so?
Yes, sir.
Yeah, I hope everyone remembers it from the power electronic side. So class A chopper will be able to provide you only from source to the load. Class B, it will go from the, I want to draw the, see what is class A chopper? A simple buck converter is a class A chopper. So it would be something like this, right? So this would be the V in, the power flow would be from power source to the load side. So this is the load. Now you have class B chopper, which would take in power from a motor or something. It is a motor. This would pump the power. The switch would be here, and then this would be the source. So it will pump back power from the load to the source. What about class C chopper? It is a combination of class A and B. So C is equals to A plus B, right? And so the power would be like this, and you need to have a capacitor attached to the parallel, and this. Hope you remember this circuit. Yeah, everyone remembers this circuit? Type a yes in the chat box.
Yes, sir.
Yeah, I want a yes from everyone in the chat box if you remember. Yeah, thank you, Akash. I think everyone else has forgotten after the semester. So please have a revision. And so what it will do for the forward for the class A operation, switch S1 has to be operated, right? For the class B operation, S2 has to be operated. And what will be a 4-quadrant chopper? It will be a combination of C type of chopper against C dash type of chopper. Means this is my own created C dash, right? So 4-quadrant chopper would be say this is another capacitor, and then this would be, I have already done it here. So this would be a, just a second. Yeah, so this would be a 4-quadrant chopper. Right? This will be a combination of 2 class C choppers, right? Okay. Now we want to have, okay, one more thing, let me tell that I have posted some PPTs and lecture notes of this subject. So I request everyone to go through the PPTs again, and the notes has been provided also. You will not be able to download it right now, right? So you have to log in into that lecture notes and then read the things. Right? Okay, so let's continue. So now we are stepping to the inverter side. So in the DC to AC converter sides, what all do we have in store? I think it's a bit of messy thing. So, sorry. So for this, we can go for a simple plain square wave inverter. Is it not so? That earlier ones which we used to have at 15,000 rupees approx, fixed voltage DC, stepped wave, semi-converter, semiconductor inverter, that would provide us a fixed amount of AC. And then we stepped on to the PWM best. So this is SPWM best actually. This is SPWM best. Sinusoidal pulse width modulation. I hope you have studied in the inverter section. And so SPWM based semiconductor based inverter. So that would provide us variable frequency also if we needed, and at the sinusoidal thing also, right? Now going for multi-level inverters, I don't hope that you know multi-level inverters, but I myself had made a multi-level inverter of 63 levels. So that was giving a complete AC. So in multi-level inverter, what we do, we make the things like this. Instead of having only, so let me show it. Yeah. So in square wave inverter, how many levels are there? Only. Say this is one level, this is one level, this is one level, right? So we have 3 levels in a square wave inverter. For a PWM, we will have several pulses like this and several pulses like this, which would amount to give a SPWM pulse. This is completely close to us having a sinusoidal wave after passing it through a filter, obviously. And finally, we have a multi-level inverter. Say we have like this inverter. Its THD is far, far lower, right? So how many levels would be there? This is 1, 2, 3, 4, 5, 6, and 0 level is 1 level. So 6 plus 6 levels in the lower field plus 1 level would give you 13 level inverter, right? So is it okay? Please give me a feedback. I don't know whether I'm online.
Yes, sir.
Yeah. So this was the short summary. And then direct AC to AC converter would be a cycloconverter where we need a variable voltage, variable frequency. So it would be step up cycloconverter or step down cycloconverter. Is anyone remembering how a cycloconverter looks?
Yes, sir.
It looks like a dual converter, right?
Yeah.
Let me draw it again for you people. So it would be like this. Diagrams are getting messed. Okay, so this would be a cycloconverter. AC supplies would come in from these edges. Yeah, so this would be, it can operate, you can operate it as a step down cycloconverter also, as a step up cycloconverter also. It all depends upon your firing of the thyristors. Right? And one more converter you have, you call it a matrix converter. I don't want to go into the details of this. So DC motors, so let's first deal with the DC motors, right? So what kind of DC motors are
Sir,
available? Yes,
sir, before you go into that, sir, can you
yes.
once again explain that DC to AC convert?
DC to AC converter, okay. So in the inverter section, what have you studied? DC to AC converters. How will you invert a signal? How will you invert a battery voltage into a AC voltage? What is the circuit of an inverter?
Sir, it was
It's similar to a what?
3 to
It's similar to a chopper. This
yes,
is a
sir.
full. This is a full bridge. This is the load. If you turn on S1 and S2, what will happen? Current will flow through this
Yes, sir.
path, and if you turn on S3 and
3 and
S4,
S2.
it will go through this,
Yes,
right?
sir.
So what is the waveform you will get? You'll be getting this waveform,
Yes, sir.
right? But this waveform has lots of harmonics. What is the harmonic content of this?
47 point something.
No, 48.3.
Yeah, 48.3.
48.3. Whatever be the magnitude of this, the THD of this type of waveform will be always 48.3%, right? So this is almost very dangerous for your apparatus, right? So people came up with SPWM. So the circuit was the same, but what they did is they chopped off the things, and it was in a particular fashion that I actually showed it in the previous semester. Right now I don't have the slide for that. So we got SPWM for this, after which the main thing was that, okay, one class I'll be showing you for the SPWM part. And you can make a filter out of it and have a good amount of sinusoidal wave. So its THD will be still lower, very,
Yes,
very
sir.
lower, right? Actually, there is a comparison chart, which for that slide, I need to again get back to it. So, and for the multi-level inverter, we have several multiple levels. Instead of chopping, what we do, we assemble some voltages and make a some type of stepped like of staircase type of waveform. So what this will give out, this will give out a THD of, I made around 61 level inverter, 61 level multi-level inverter, 30 levels above, 30 levels below, right? So that was around 61 level, and it had a THD of around say 1%, 1 or 1.5%, right? So it was like working like magic, right? So perfect. Instead of 48.3%, we got a THD of around 1%. So it was absolutely miraculous thing. Anyways, I deassembled the circuit again. I need to assemble it again. So we have the video of that also. Okay, so is it okay with whatever was taught today? I think it's already time. It's up to 11:50,
Yes, sir.
right?
Yes, sir.
So DC motors will be starting in the next class. So please go to the content section. Here you will get the PPTs. You will get the lecture notes of the subject, entire notes, right? 5 units, everything is there. You can start studying it from today itself, right? Okay, so any more doubts for today?
No, sir.
Let others speak out also. Let others speak out also. Do you want any improvement in the classes? If any, please post in the chat box down. See, it has to be a both-sided end, right? If you don't give me a feedback, how will I understand what you need? I can give you everything, but you have to tell me what you need. Is the speed very fast? Is the speed of teaching very fast? Just give me an answer in yes and no. Others, please respond. Okay, do you have any problem with the background music that I obviously play for a better experience? Shiv Kumar has told me yes. So please tell me your problem with the thing. Please unmute yourself and tell.
Sir, background music, that turn, I don't want to hear that.
Okay. Anything more? So why don't you get me a good background music for everyone? downloadable. Yes, I will make the notes downloadable. So, okay, I can post it in the WhatsApp group, right? So Shiv, can you give me a good background music? I will download it here, which will be good for everyone. Can you do that, Shiv?
Yes.
Yeah, please provide me the link. I will just download it and play it. So that will be very low tune. That is
Why don't
actually
blank?
good. Yeah.
Why we are putting black background music? Why don't it be
Yeah,
blank?
because that's a thing of the psychology, right? In every good hospitals you go, they always play a good background music. So this has a connection to the psychology. So you will be relaxed and hearing in the class, right? So that's the secret. So if you don't like the music, we can change it, but we will play it very low tune, right? So if everyone doesn't want that background music, I can stop it also. No issue with that, right? So first of all, try to give me your own choice, which everyone would like. And then if everyone doesn't like it, I can stop it also. No issues. So I will make the notes not downloadable. I will send it to your WhatsApp group. I don't know which group you are in, so I have to find it out. So any more doubts? Just open up. No issues. Don't worry about your marks. Your marks will not get decreased if you ask questions. Okay, are the slides interactive? So are the slides interactive? Yeah, please reply it. Okay. Anyone having problem with the slides? Okay, so please remove this window from the shared application. Yes, Puran, I have been trying to remove this window from a long time. I don't know how to do this thing. I have been trying much. I don't know what to do
Sir,
with
it
this thing.
appears
In
only
every
in
class
your
it comes
class.
up. Yeah,
So
right?
I think
So I don't know where this thing comes up.
so you can ask from other teachers like
I don't know.
so
Yeah. I'll try to fix it up. Every time this comes out. Anyone else? Okay. So meet
sir,
you in the next class. Next class is
sir.
yes.
Make the notes downloadable, please.
Yes, tell me. I won't make it downloadable here. I will post it in the WhatsApp group, right? It's a small thing. So I'll post it in your WhatsApp group. Don't worry. I won't make it downloadable because that's not the norm of lecture notes to make it downloadable. Right? I'll post it in the WhatsApp group. Just ping me up in the WhatsApp. Right? From the
Okay,
group,
sir.
anyone just ping me. Right? Okay. Okay. So meet you on Tuesday 2 to 2:50. Right. Yeah. Okay. Thank you.